Let's look at almost the same example, just a little more detail. Another very similar related idea of an extended ratio. Uh, the U.S. specifically, we often care not about the total metals, but about gold, silver, and bronze. So the U.S. has 24 gold, 31 silver, and 32 bronze metals to make up this total that I said before. Um, and then we know the Australian total is 37 metals. If they had the same gold to silver to bronze ratios, and I will reveal their actual numbers in a little bit, but suppose they had the same proportions, the relative proportions of gold versus silver versus bronze. So we see silver and bronze are very similar to each other, essentially equal, but we'll make that a little more precise. And they're both a bit bigger than the gold ratio. Suppose we scaled that down. We know that that total is 87. Suppose we scale down the total to match the 37 Australian metals. What numbers would we get for gold, silver, and bronze? And then we can compare it to what the Australians do to see if the Australians are still awesome or not. And so we what we call this is an extended ratio. This is where the notation of having colons is very useful. We'd say it's a 24 to 31 to 32 ratio of gold to silver to bronze. And that means that right, we're taking those from the actual numbers of gold, silver, and bronze. But what we're going to do is we're going to say what are other triples of numbers that are in the same relative ratios of the three numbers, but not necessarily being exactly those same numbers. And we want a new triple of numbers with the same ratio, different total. And this is something where we again introduce a variable, but in a somewhat different way. What we're going to say is we're going to say that we're going to observe that to create other triples of numbers with the same relative ratios, we're going to take some unknown x that we're going to figure out in a minute, and we're going to scale up the 24 by x and the 31 by x and the 32 by x, or we might be scaling down if x is a small number. And any triple of numbers, 24x and 31x and 32x, will have the same relative sizes because I've scaled them by the same x, but they'll have a different total. Okay. And how do we figure out x? It's because that we know what the total is. So the prediction for Australian gold is going to be 24x, and the prediction for Australian silver is going to be 31x, and the prediction for Australian bronze is going to be 32x, and we know we want that to add up to 37. Okay, that's not too hard. We can just factor out an x here. Great algebra practice, factoring out some quantity, and then of course, this is a kind of a familiar quantity. This is actually the 87 again. So x, well, let's say 87x equals 37. This is really the same kind of number that we had in the first video in disguise. 37 over 87. It didn't actually come out numerically. This is the Australian to US ratio. It's the scale factor. Let's just do that much precision. That says if I want to scale the American total down to the Australian total, I'm going to scale everything down by multiplying by 0.425. And then now I need to go back in and say, okay, well, what is 24x? 24 times 0.425. Okay. That's going to be 10.2. I'm going to leave the 0.2 in there, even though you can't get a fifth of the metal. But so we would expect a little over 10 golds. 31x. So we take the American silver total and we scale down by the appropriate scale factor to translate to an Australian prediction. And I need it to actually calculate that for me. About 13 point, I'll say 13.2. I'll round it again a little bit. So we'd expect a little over 13, and then 32x. And that should be a little bigger, about 13.6, about 13 and a half. That's bronze metals. So let me note that. So this is our prediction for gold, put a little question mark because this is a fictional prediction. This is what would happen if we took the mix of gold, silver, and bronze that the U.S. is getting and scaled it down to a country with the size, population size of Australia, and then we're going to compare. And so that's what I'll do now. Pause. Okay, so it turns out I looked up the real Australia. They got 15 gold, 12 silver, and 10 bronze. It's not ridiculously different, but I'm noticing that they're overperforming significantly in gold medals. It's a really close on the silver, and of course, it's made up for by the fact they've got extra gold somewhere they have to underperform, and it's pretty good for them. They're underperforming the prediction in bronze and trading out some of those for gold, right? So again, Australia rules. Okay, not only do they have this phenomenal total per population, but they actually get more gold than silver and bronze, whereas the U.S. gets more silver and bronze than gold. So these are pretty simple calculations, but they all rely on ratios and proportions to make sort of fair comparisons between the two countries. So I think that's kind of fun, and this is exactly what I do in my head when I look at these medal totals. There was a great graphic in the New York Times that had made a cool graph with all these ratios and talked about small countries and big countries and comparing them in terms of medals per population and exactly these kind of comparisons. So people really do this.